Okay, so this is lesson 5.1a, and we're starting on probability. So the only mathy section of stats is probability. If you had to get, it'll seem like the Algebra 2 probability stuff you did. That'll help you if you've had that. But it's, starting with, so this is the one section. It's about 10% of the test or so, maybe a little more. But it's not a huge part of the test, but it does get a little mathy. Definitely calculator use on this one. But first, let's just understand the concepts. A random process generates outcomes that are purely by chance. A trial is one repetition, so we might have 500 trials. You flip the coin 500 times. That's a trial. Each one is a trial. So the first slide there, I just want to make sure you understand, that's the result of 10 tosses. So, for example, if you tossed a coin, it looks like their very first toss, the proportion of heads is on the left. So the very first toss, I can tell, was a heads because 100% of the tosses at that point were heads. The second toss, it looks like it goes down to the 0.5 there because it must have tossed tails. So they've got two tosses, heads and tails. So they're right at 50%. And then the third toss looks to be a heads because 2/3 is right there. The fourth toss is a tails, so they're right back at 50%. The fifth toss is a tails. Sixth toss is heads, so they're right back at 50%. And then they proceed to have 4 more tails, so they're below 50%. Now what's going to happen is maybe that same thing, if you keep going or you did 500 of them, what's going to happen is it's going to keep going closer and closer to the mean there. So that's what this is about to say, I think. So first 10 tosses are there. We're not that close to 50%. We're at like 0.3-ish or 30%-ish. But when you have 500, you can see that it's going to be very close, much closer to the 50% we expected. So the probability is a number between 0 and 1. So you can't have a negative probability. You can't have a probability of more than 1. 1 would be, perfect chance, like it's going to happen. 0.5 is 50% of the time it's going to happen. But that's only on a very long series of repetitions. So the first concept has to do with this idea of, it's going to approach 0.5 if you flip coins over a lot of tosses. So as the number gets bigger and bigger, in fact, that has a name. It's called the law of large numbers. If we observe more and more repetitions of the same chance process, the proportion of times the specified outcome occurs approaches its probability. In this case, flipping a coin is going to very much approach 50% if you do enough tosses, 500, 1,000, 2,000, etc. Some people distinguish between tossing a coin just a couple times to estimate probability of a head. Empirical probability using a computer is called a simulation to simulate this process. So we can use, of course, our calculator to simulate a coin toss, rand int 1, 2, and however many you want. But actually, probability is actually predictable in the long run, right? So that's actually true. We sometimes try to use long-term odds to predict the short run. We're not very good at predicting the short run. It could be heads a bunch of times, tails a bunch of times in a row. That certainly happens. They use the phrase law of averages, which is is kind of a misguided belief that the chance will even out in the short run. In the short run, they might not even out, but in the long run, they kind of will. Okay, so interpreting probability. So just examples, Chicago Cubs play their home games at Wrigley Field, located in the Lakeview neighborhood of Chicago. A recent New York Times study concluded that the probability that a randomly selected Lakeview resident is a Cubs fan is 44%. Interpret that in terms of a long run relative frequency. So, if you if you pick many different Lakeview residents and ask them if they're a Cubs fan, maybe 1,000, 2,000 of them, that the average will be very close to 44% is what we're saying here. If a researcher randomly selects 100 Lakeview residents and exactly 44 of them be Cubs fans, well, most likely no. I mean, there's something called, sample variability, right? So the next sample may be totally different than the first sample. If we take enough samples, we might get a better idea, but that's the idea of it. So If you take a very large random sample, about 44% of them will be Cub fans. In this case, probably not, only 100. The number of Cubs fans will not be that close to 44. It probably won't be exactly, very likely. Okay, that's your quick lesson for today. Be sure and do the homework. It'll give you a better sense of what this is talking about, the long-term probability average.